I'm Hannah Mahon. I'm a research scientist at the Georgia Tech Research Institute. My work involves um, formal verification of both software and hardware and FPGA analysis. And then also some of my work has recently included FHE. I first heard about FHE last year. I was introduced to it when I started taking more of a research focus on group theory and group theoretic applications. So that's how I found FHE. Um, I thought the concept is really interesting, like how it's based on rings built on polynomials, and then I also thought it was really interesting how this data can be rotated or maneuvered. So there is like a really nice mathematical element to it that I thought was cool. So in theory, I think having a precise FHE scheme is nice, like BGV, but I would say probably my favorite is CKKS for the practicality. Um, I am interested in applied math, and sometimes I think approximations are okay in real life. I would say like there are two elements for why I wanted to work in it. Probably like the like academic reason would be I like the math involved. Um, I think there's a lot of room for like understanding the underlying theoretics in ring theory and being able to exploit that for faster algorithms, especially like when they're like more higher dimensional uses in FHE. And then for practicality, like I do really like the secure aspect. I like that we're working on something that offers data security and is going to offer data security in a post-quantum era, hopefully. I think the most difficult challenge was knowing the math that we wanted to do and then implementing it into the software. So yeah, somehow the pen and paper ideas were nice. And then for me, at least, it was a big learning curve getting into the softwares. So we touched HElib, we touched Microsoft Seal, we touched OpenFHE, and going through the documentation and like figuring out how to do more custom things, like um, defining our own automorphisms was definitely like a little bit of a learning challenge. Now it's like a lot better, but that was probably like the hardest ramp up thing. I think being involved in the community, I want to see it advanced. So like I want to see it advance. So I'm a bit biased there, but I think I would say it depends. Maybe like the speed of advancement depends on funding, and then funding I think depends on how relevant things are in real life, like how much of a need there is. And then that I would say is like, I don't know about primarily, but like a big factor would be driven by how quantum computing is going. So there's a lot of attention on that, but I think it depends. Like if something exists that can like break our encryption right now, like RSA, then I think FHE will be extremely relevant, and we'll see a lot of speed ups. But yeah, but maybe for like a more realistic direction, I think there's a lot of room for hardware acceleration. I know like DARPA's put a fair amount of money into focusing on that. Maybe as a software person, I'm like a little more excited about the theoretical aspect. So um, I think it'll be like kind of a marriage of like all of these different areas. I think I would like to see like a little more hands-on uh, work done, like for where this can be useful. Sometimes when I've been to talks or conferences, it gets like immediately deep into the theory or like deep into minute computer speedups. And it would be nice to have like a little bit of focus on how things can be used right now. So maybe less of like an exciting research aspect, but more of like a practical viewpoint.